Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. If you saw my previous video on adding, subtracting, and multiplying polynomials, I'm sure you were wondering what happened to dividing. Dividing gets its own special place because there's also two types of dividing. So in this video, we're going to go over both of them. We're going to go over long division and synthetic division. Some of my foreign exchange students have called this Ruffini's, and that just goes back to the person who went ahead and first introduced it. Synthetic division can be used sometimes. Long division can be used for any problem. There is also something called term-by-term division. This only works when dividing by a monomial. And you actually have kind of already seen these with the term-by-term division. For example, if I have 4x squared plus 8 and I divide it by 4. Well, 4 is an example of a monomial. The numerator is a binomial. And so I just have to rewrite them as two separate fractions. Where I take each part of the numerator and I put it over the denominator, and then I can reduce. So the focus of this video is really not that term-by-term division, because dividing by a monomial is just spreading out your fractions and reducing each term. Our focus is going to be today on long division and synthetic division. So we're not going to be dividing by a monomial. So before we get into actually dividing a polynomial, let's go back and just kind of review, how do we divide? So we're going to take 4,273 divided by 12. So when I was in school, we used this for a division sign. 4,273 divided by 12. And I know they do partial quotients and things like that now in elementary school, but I do believe they still teach this method. If not, let me know, drop something in the comments, and I can go over it more in depth if you don't pick up on it. Okay, so we're trying to get 12 to go into this number. So does 12 go into 4? No. Does 12 go into 42? Absolutely, yes. It goes in 3 times. Now we know 3 times 12, and we're multiplying by the 12 because it's what's up front, is 36. And then after that, you subtract and bring, you can either bring everything down or just bring the next number down. I like to just bring the next number down. So now we're looking at, does 12 go into 67? The answer to that is yes, 5 times. So now we're going to take 5 and multiply it by 12 because that's what's out front. And that would be 60. And then we're going to subtract. And 60 minus 7 is 7. Then we're going to draw arrows to remind ourselves we brought things down. We're going to bring the 3 down. Okay, now does 12 go into 73? The answer is yes, 6 times, because 6 multiplied by 12 is 72. And then we're going to subtract. We have a remainder of 1. So we can say 4,273 divided by 12 is equal to 356 plus a remainder of 1 out of 12. remainder 1, right? Or we can take that same statement and say 4,273 is equal to 356 times 12 plus 1. So depending on how the directions, if they want you to write it, most of the time in Algebra 2, we're going to write 356 plus 1/12 or 356 remainder 1. But I wanted to make sure that we understand that these are both true statements. One is written where the 12 is a multiplier to the 356. The other is written where 12 is the divisor on the other two. So both statements are correct. This one's written where the problem equals the answer. Okay, that's not really our goal today. Our goal is actually to do this to polynomials. So why would I practice all that with numerical? Well, I wanted to remind you of the pattern. So draw a line here, that way we know the difference between one work and the other work. Now we're going to do 2x cubed minus 5x squared plus 4x minus 6, and we're going to divide that by x minus 5. Whew. Okay. So we're going to start off the same way. The x minus 5 is the divisor, so it's going to go up front. Let me scooch that over a little. I have a reason for wanting to scooch it over. And we're dividing by the 2x cubed, well, sorry, I said that backwards, is dividing, not dividing by. Okay, I scooched it over so I could have the same kind of work out to the side. So our goal is to get as close as we can to the term without going over. So in this first case, I have to multiply x minus 5 by something to get it as close to 2x cubed as I can, so that the 2x cubed is going to cancel out. So instead of saying as close as I can without going over, I want to match the first term. So if I multiply by 2x squared, when I take the, just like I took the 3 times the 12, I'm going to take the 2x squared times the x minus 5. 2x cubed minus 10x squared. Okay, and then we're going to subtract. Now here's where the biggest mistake happens, is sign errors. So be careful. So the first thing we're going to do is 2x cubed minus 2x cubed, and that goes away. Then we're going to do negative 5x squared minus negative 10x squared minus negative. Negative 5 minus negative. Let's just write that down real quick. Negative 5 minus negative 10. There's that double negative. Oh, so it's really negative 5 plus 10, which is 5. Bring the next part down. So sign errors are going to be our biggest issue when doing long division. Okay, so just like before, we tried to find a number. We had 67. We were trying to get as close to it without going over. That's why we picked 5. So again, we're going to have to multiply it by an x minus 5. We're trying to get as close to 5x squared without going over. So if I multiply by 5 and I multiply by x, my first part will match. So I'm multiplying by 5 and x, so put plus 5x. 5x times x is 5x squared. 5x times minus 5 is negative 25x. And now I need to subtract that. Okay. 5 minus 5 goes away. 4 minus negative 25 becomes 4 plus, or use a calculator. And then we're going to bring that next number down. Okay, now we're trying to get as close to 29x as possible for our first part. We're at x, so we're going to multiply by 29. So that'll give us 29x minus 5 times 20 is 145. Yeah, 145. And then, again, we have to subtract that. Negative 6 minus negative 145 is 139. So that's our remainder. So our answer would be 2x squared plus 5x plus 29 plus our remainder over our divisor. There is a really cool trick about the remainder theorem. This problem was originally 2x cubed minus 5x squared plus 4x minus 6 divided by x minus 5. And when we did that, we got this answer. Okay. Now, hopefully you would agree that the number that zeroes out the x minus 5 is 5. So I'm going to go ahead and substitute 5 into what I divided, the 2x cubed minus 5x squared plus 4x minus 6. I'm just going to substitute it into that part. It gave us a remainder. That's how you can check your work on a lot of problems, is you can check your remainder. So it's called the remainder theorem. Okay. Get the bright light going here again. So if you have a polynomial and you divide it by x minus a. Now notice there's no power on the x and there's no coefficient. If you have that, then p of a will be your remainder. And this is going to be a really handy tool, the remainder theorem. You're going to use it a lot more than you think eventually. You'll forget that you're even using the remainder theorem. But anytime you want to check if your remainder is correct, you can check using your remainder theorem, assuming that you have a linear divisor with a lead coefficient of 1. So again, all I did was I took the a value, the 5, and I substituted it in to the 2x cubed minus 5x squared plus 4x minus 6. And that's how I found out just my remainder. Is it good all the time? No, but if you're looking for perfect divisors or you're trying to factor and you're like, oh my goodness, I don't know what a factor is, it can actually help you. So that's a cool trick. Because if it equals 0, if the remainder is 0, you found a factor. And in future videos, I'm actually going to go into that more in depth. That's not the focus of this video. The focus of this video is just practicing dividing. Okay. X cubed plus 8. We have factored this before. It's a sum of 2 cubes. If you know the sum of 2 cubes rule, you know that the answer to this is x plus 2 times x squared plus 2x, whoops, not plus, minus, plus 4. But I'm going to bet most of you probably don't like memorizing that rule. You're like, okay, I can get the x plus 2 part. It's that second parenthesis I can't get. That's where this is going to come in to help. your long division, your synthetic division, it's going to be great to help you. So let's say you can't remember how to factor x cubed plus 8, but you know that you have the power to divide. Well, the only problem with division is placeholders are mandatory. Okay, we must have placeholders. Now, some people, as they get more advanced, they just leave spaces. But for now, we're going to actually fill in our placeholders. And the reason is because this went from a cubic term to a constant term, and it skipped over the other terms. So we have x cubed. They skipped over x squared. They skipped over plain old x. And then they had an 8. No, that's not ox, that's 0x. So that's what I mean by placeholders. I put in 0 divided by x plus 2. Okay, this time I'm not going to write out the multiplying to the side because that's a little extra. So we're going to kind of just work it out together. We're trying to get up to x cubed. I need to multiply by x squared. So x squared times x is x cubed. X squared times 2 is 2x squared. And I'm going to subtract. One minus 1 cancels out. 0 minus positive 2 is negative 2. I'll bring the next part down. All right. Trying to go from x to negative 2x squared. So I've got to multiply by a negative 2, and I need one more x. Negative 2x times x is negative 2x squared. Negative 2x times positive 2 is positive, whoops, not positive, negative 4x. Ooh, I almost had a sign error there. We're going to subtract. Negative 2x squared minus negative 2x squared goes away. It should, that's why we chose it. 0x minus negative 4 makes plus. And I'll bring down the next part. Now I've got to multiply x times something to get it to 4x, so there's a 4. 4 times x, 2 times 4 is 8. And when I subtract something by itself, it is a remainder of 0, which it should be because this is technically x minus negative 2. So when I take that negative 2 and I substitute it into the top, negative 2 cubed plus 8 does indeed equal 0. My remainder should be 0, and it was. So now we can either say x cubed plus 8 divided by x plus 2 equals x squared minus 2x plus 4. Or we can say x cubed plus 8 equals x squared minus 2x plus 4 multiplied by x plus 2, which, hey, doesn't that match that factoring rule? So if you don't have the factoring rule memorized, it's okay. You don't have to have the identity memorized. You can find it by division. Whew. Okay. Again, long division works 100% of the time. You must have placeholders. However, it takes up a lot of space and sign errors happen frequently. Enter synthetic division, or as some of my foreign exchange students know it as, Ruffini. Okay. Synthetic division is an option. If p of x is divided by x minus a. Now, Technically, it could be x plus a as well, okay? Basically, it needs to be a linear divisor with a lead coefficient of 1. Okay? Now you might have noticed both of the problems that we did so far actually fit this category. Our first problem was 2x cubed minus 5x squared plus 4x minus 6. And we divided that by x minus 5. And then we had x cubed plus 8, and we divided that by x plus 2. These both have synthetic division as an option. So the thing with synthetic division is we're going to do like a backwards L. And the a value goes inside there. And the coefficients go on the side, the coefficients of p of x. Okay. So in this case, it was 2, negative 5, 4, and negative 6. And our a value is 5. Okay, you'll leave a work line. You'll draw a line, and then this part here will be your coefficients of your quotient, and over here it'll be your remainder. And your coefficient will be 1 degree smaller than you started. Okay, the way this starts is you bring the first number down every single time. It's got to come down below the line. Then the number that's here, our a value, is our multiplier. So 2 times 5 is 10. And then you add. Negative 5 plus 10 is 5. Then you multiply. 5 times 5 is 25. Then you add. 29. And then 5 times 29 is 145. And then you add, and you get 139. And again, we multiply by that blue 5 each time, by that a value. Why a? Because that's the letter I used. So since this started off x cubed, since this is x cubed for starting, this will be x squared for starting. 1 power less, 1 degree less. So 2x cubed plus 5x squared, squared x, forgive me, I was reading that, plus 29 with a remainder of 139 out of our divisor, x minus 5. And if you look back, 2x squared plus 5x plus 29 with a remainder of 139. That's exactly what we got, especially once I fixed my little boo-boo that I almost made. Don't make that boo-boo. Okay. When it comes to this other problem, we had to have placeholders when we did long division. We must have placeholders when we do synthetic division. The biggest error I see in synthetic division is people skipping over things. So remember, you have your quadratic term, your cubic, quadratic, linear, and constant. You have to have a number for all of those since we're starting at x cubed. 1, none, none, 8. Now, if you remember, this is x minus a, but this has x plus 2. That's the same thing as x minus negative 2, right? So we're going to put a negative 2 right here. Or you can think, hey, what makes that equal 0? What makes that equal 0? Sometimes people think it's easier like that. What makes it equal 0? So that's why we're putting that number right there. That's our multiplier. First number comes all the way down. Multiply, add, multiply, add, multiply. And we get, that started off x cubed, so this is going to start off x squared. I'll do it right this time. So there we go. Okay, so is x plus 2 a factor of 4x to the 5th plus 3x fourth minus 5x cubed plus x squared minus 2x plus 8. There are two ways to do this. Okay? We can either actually divide it, or we can do the remainder theorem. So let's do actual division first. This one is eligible for long division as well as synthetic division, so I'm going to use synthetic. We're trying to divide and see if it divides perfectly, because a factor is a perfect divisor. So I'm going to use -2 here. There's the quintic. No, not yeah. To the 5th power, to the 4th power, to the 3rd power, to the 2nd power, to the 1st power, and then our constant. So 5, 4, 3, 2, 1. Okay, they did not skip any. Okay, come right before the first one. This is going to be our remainder. If it's 0, it's a factor. If it's not 0, it's not a factor. Okay. Bring the 4 straight down. Remember that first one always comes straight down. Then we're going to multiply by -2 and add. Multiply, add, multiply, and then add, multiply, add, okay. No, the remainder does not equal 0. It's not a factor. Okay, we could have done that, or we could have done the remainder theorem. Before I do that, just a note. The answer to this division would have been 4x to the 4th minus 5x cubed plus 5x squared minus 9x plus 16 plus -24 over our x plus 2 divisor. Just in case you were wondering, make sure that we understand that. A remainder theorem, we would have just done 4 times -2 to the 5th plus 3 times -2 to the 4th minus 5 times -2 to the 3rd plus -2 squared minus 2 times -2 plus 8. And then Notice I'm putting the powers on the outside of the parentheses. That's very big. And there's that remainder, negative 24, which is what we said it would be. So 2 ways to figure out a remainder, and that is to either actually divide it or just use the remainder theorem. So synthetic division works right along with the remainder theorem, but please make sure that if there's a coefficient or a power other than 1, then you'll want placeholders. Just a quick note as well. Let's say you have 8x to the 6th plus 6x to the 4th plus x squared divided by x squared minus 1. In this case, I'm going to overuse placeholders out of abundance of caution. Okay? This one cannot be done synthetically. It has to be done long. So we had 8x to the 6th. They skipped x to the 5th. I'm going to go ahead and make this minus 1x as well. Then they had 6x to the 4th. They skipped x to the 3rd. Then there's an x squared. They skipped plain old x, and they skipped the constant. Then we had x squared minus x, but they skipped the constant. You can put placeholders out here as well. So that's something else to keep in mind. And I'm going to go ahead and do this one. We would need 8x to the 4th. That would give us 8x to the 6th minus 8x to the 5th plus no x to the 4th. And we've got to subtract all that. That would give us 8x to the 5th, 6x to the 4th. Bring down the next term. So now I need 8x to the 3rd, x to the 5th, minus 8x to the 4th, no x to the 3rd. You can pause this as you need to. I'm just demonstrating this time. Six minus negative 8 is 14. So I need 14x squared. Subtract all that. And you might say, well, how do I know when I'm done? You are done when your exponent of your remainder is smaller than your divisor. I'm still at x squared. That is not smaller than x squared, so I got to keep going. Okay. And then I hit it. Now I have a smaller power than that, so my answer is 8x to the 4th plus 8x cubed plus 14x squared plus 14x plus 15 plus a remainder of 15x over our divisor. And that's how I would write that answer. So again, this one was not eligible for long division because it's had a squared in there. So our goal is to have the smallest numerator possible. Your power of your numerator needs to be smaller than the power of your denominator. Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? and drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.